Recall that in order for you to calculate the standard Gibbs free energy, ang formula na gagamitin is this, minus RT ln of the equilibrium constant. Now, what we will do is we will solve for ln of k. So, ang mangyayari, magiging equal siya sa negative Gibbs free energy standard divided by R times the absolute temperature. Now, recall that your delta G, okay, is equivalent to delta H minus T delta S at constant pressure and temperature. So let's go ahead and insert that in our equation here. Ln of K magiging negative delta H of the reaction, okay, if we're talking about a chemical reaction here, plus T delta S divided by RT. Now, let's try to simplify this equation a little bit. So, magiging ln of K equals negative enthalpy over RT plus T delta S over RT that will simply reduce to delta S over R. And ang gawin natin, let's replace this constant here, or not really a constant, but this expression delta S over R as A. So that your equation will become ln of K equals negative enthalpy change over RT plus A. Now, if you want to express this or transform this equation into an exponential form, so magiging K na lang siya dun sa left-hand side equals E raised to negative delta H over RT E raised to A. Right? And it will simplify to K, or the equilibrium constant, equals a constant, this one, tawagin natin siyang A prime na lang, E raised to negative delta H over RT. And this equation is what is known as the Van 't Hoff equation. So this equation will calculate your equilibrium constant at a given temperature. Alright? Now, if we want to compare the equilibrium constants at different temperatures, so let's say you know the value of K at a certain temperature and you want to determine its value at a different temperature, ano ang gagawin natin? So, what we will do here is we will simply compare two equations. So, yung isa is K2 equals A prime, let's have that as constant, and then E raised to negative delta H over R T2. Ibig sabihin, at a certain temperature T2, ano yung equilibrium constant K2. And let's say na alam mo yung K1. Okay, ibig sabihin, K1 is known. Okay, and then you have the pre-exponential factor, E raised to negative delta H. Delta H here is also constant, divided by R T1. So what happens here is, you will be able to determine the ratio of K2 and K1. Alright? And it will leave you with, in the right-hand side of the equation, magiging E raised to negative delta H over RT2 plus delta H over R T1. Simplifying this equation, so what I'm gonna do here is I'll just take the logarithm of both sides of the equation. So magiging ln of K2 over K1 equals negative delta H over R times 1 over T2 minus 1 over T1. So this is another form of the Van 't Hoff equation. Okay? So the Van 't Hoff equation basically is an equation for you to determine the temperature dependence of equilibrium constants. Okay? Ang maganda dito kapag na-memorize mo itong equation na ito, mayroon pang dalawang equation sa chemistry, at least dalawa. Pwedeng mas marami pa, but there are two very known equations na kamukang kamuka ng equation na yan. So yung isa is yung, although this is out of topic already, yung isa is yung ln K2 over K1, and I'm writing here small letter k, hindi equilibrium constant, equals negative E sub A over R 1 over T2 minus 1 over T1. So if the first equation here is the Van 't Hoff equation, this equation that I've just written is the Arrhenius equation na ginagamit sa chemical kinetics. We will not apply this equation right now kasi sa kinetics part siya. But as you can see, kamukhang-kamukha niya yung above equation. So it's good to memorize one of this, right? This K values here refers to the specific rate constants, and the E sub A refers to the activation energy. Meron pang isa, yung ln of this time P2 over P1. At makikita nyo to later on in one of our discussions in phase equilibria. So that would be negative delta H VAP, okay, enthalpy of vaporization over R, okay, times 1 over T2 minus 1 over T1. Diba? Kamukhang-kamukha niya, and this is your Clausius-Clapeyron equation. But anyway, let's focus our attention to the first equation, which is the Van 't Hoff equation. Now, let's have an example. So let's say you're a biochemist and you're studying a certain protein, and this protein is in its folded state, naturally, right? But you want to kind of unfold the protein by using some kind of reaction, okay? And you're given here various temperatures wherein you sample the reaction such that you are able to determine the equilibrium constant at these different temperatures na nakatabulate right now. Now, ang gusto nating mangyari dito is we want to estimate the following: the enthalpy of reaction, maybe because you want to determine whether the process is endothermic or exothermic, and yung delta S, for example. Okay, so this is delta S. You want to determine kung spontaneous ba siya or hindi. And letter B, you want to determine also the equilibrium constant at 373 Kelvin. Okay, so kung mapapansin nyo yung data in this mini study that we have, yung equilibrium constant ay maliliit. Okay, so at 290 Kelvin, for example, that's 0.12. At 295, that's 0.25, etc. Remember, if K is less than 1, the reaction or the process is medyo hindi siya favorable. Okay? Nagiging favorable lang siya kapag ang K is greater than 1. And it only starts to be spontaneous at the temperature here, which is 305 Kelvin. Okay? So how do we answer or how do we solve this problem? So ang gagawin nyo lang is gagamitin natin si Van 't Hoff equation. So ano ang itsura ni Van 't Hoff equation? That's K equals A prime E raised to negative delta H over RT. Now, ang gagawin natin dito sa equation is we will linearize. No? And the way to linearize this is probably we can get the logarithmic form of this equation. So, ginawa na natin to actually kanina, but let's do it again. So, ln of k is simply ln of a prime, okay, minus delta h over rt. So, now you have linearized the equation, yung Van Hoff equation natin, such that yung ating equation na yan represents an equation of a straight line, right? So, ibig sabihin, pwede mong gawin to, yung ln of k, as your dependent variable. Tapos, this one is your y-intercept. Okay? Yung ln a prime. And then, yung x mo dito is negative, or rather, positive 1 over t. So, therefore, you have to get the reciprocals of the temperatures. And yung slope mo dito is negative delta H over R. Okay, as you can see or inspect in the equation. So you have to take a plot, therefore, of 1 over t in your x-axis versus ln of k in your y-axis. So let's do that in Excel. So here I tried to obtain the plot. So again, meron kang temperature and equilibrium constant, and then I created the column for the reciprocal of temperature, okay, and the ln of k kasi sila yung ilalagay natin sa coordinates. So take the plot, okay, I was able to create a scatter plot, and ito yung lumabas na equation ng line. Alright, y equals negative 12,606, x plus 41.346. And if you look at the r squared value, it's equal to 1. So, ibig sabihin, our line is quite perfect. Now, ang gagawin natin is, we will inspect the equation. So, if you take a look at the equation, ang sinasabi niyan is, yung slope daw is, what? Negative 12,606. Okay? But ano ba yung slope? Remember, yung slope natin from our equation is what? This, no? Negative delta H over R. So, negative delta H over R. So, magkakaroon ka ng delta H value that will be equal to 104.8 kilojoules per mole. So, this is now the answer sa letter A. Kasi R is a known value, right? So, you just have to multiply the value of R, 8.314, by 12,606 and convert it to kilojoules per mole. So, that's your enthalpy. And as you can see, the reaction or the process is endothermic. Now, another question in letter A is we want to determine the entropy of the process. Okay? So, in order for us to determine the entropy, you have to recognize that yung y-intercept natin from our result, so the y-intercept, okay, is equal to 41.346. Okay. Now, remember, the y-intercept is equal to ln of a prime. So, ln of a prime. But what is a prime? So, a prime is simply e raised to a. So, therefore, yung 41.346 natin is just equivalent to a. But what is a? A is just your entropy divided by R. So, therefore, makukuha mo si entropy as 343.8 joules per mole Kelvin. So, yung ating entropy ay positive. And lastly, for letter B, gusto daw natin malaman yung K at 100 degrees Celsius or 373 Kelvin. So, paano yan? Ang gagawin lang natin is gamitin lang natin yung equation of the line which is coming now from your Excel plot. So, what is that? Yun yung ln of k equals negative 12,606 times 1 over t plus the intercept of 41.346. So, minus 12,606 times 1 over 373 plus 41.346. So, yan yung ln of k. And you will be able to compute k as 7.5. And this is a highly or pretty high value for equilibrium constant for your protein unfolding. And we can say that the process is favorable.